Hello, welcome, welcome, welcome to my YouTube channel. This is Philip No. I hope you're fine. I'm good, I thank God. So, in today's class, we are going to examine some basic algebraic properties of complex numbers. And before I start explaining, uh, uh, it's just a humble request from me. If you're new to my channel, first time you're seeing me here, kindly do subscribe and hit a bell notification so that the moment I'll be uploading a new video, you'll get notified about it. Thank you so much. Enjoy. Let f be the map sending each complex number z is equals to x plus yi, which is equals to x, while this matrix, as you can see, it's written in matrix form. Show that f z1 z2 is equals to f z1 f z2 for all z1 z2 belonging to this. So solution: I have a proof. You can just a proof. Let zk be equals to xk plus y ki, for k is equals to 1, 2, then z1 z2 is equals to, so z1 z2, if zk is equals to xk plus yki, z1 will be where we have k, put 1, so z1 will be x1 plus yki will be y1 I. Right there. Then z2, where we have k, we will put it 2, so z2 will be xk will be x2 plus yki will be y2i. y2i. Are we there? Now we have x1 plus y1i, x2 plus y2i. We get the product of this. X1 times x2 is x1 x2, x1 times y2i, positive is positive, x1 y2i, then plus y1 I times x2 will be x2 y1i, then plus y1i times y2i will be 1 y1i y2i. Are we there? Now we collect like terms, separating the real and imaginary parts. Now we have x1 x2. Are we there? Or before we separate, there's something I have not tackled here, so let's write it first, then we separate. Plus x2 y1 I square times I times I is I square. Remember, the square, the I squared is equals to -1, since the square root of -1 is I, so I squared is equals to 1. I'm saying that, can recall I squared is equals to negative 1. So remember, we have y1i times y2i. y1 times y2 is y1 y2. I squared times I squared y times I is I squared, and I squared is equivalent to negative 1. So here will be minus y1 y2. Are we there? Then now we separate the real and imaginary parts, and we have that x1 x2 minus y1 y2 for the real parts, then plus x1 y2, this one, plus x2 y1 I. So this the imaginary part. The part containing I is the for imaginary part, and this is the real part. And remember, you have been given the question that z x x plus y I is equals to this matrix. So can say the hence f z1 z2 is equals to, remember, in this x is for real part, and then y is for imaginary part. Are you seeing what I'm saying? Are you getting what I'm saying? So x here. So here we'll put a real part, here imaginary part, here a negative of the imaginary part, then here a real part. Hope you understand. I'm saying that in this expression, x is for real part and then y is for imaginary part because it's containing I. So in writing in this form, or this matrix form, x, this part for x will stand for real part, y for imaginary part. This for negative of imaginary part, and then x for real part. So in this case, since we have gotten f z1 z2 as x1 x2 minus y1 y2, this for real part, plus x1 x2 plus x2 y1 plus x1 y2 plus x2 y1 in brackets I as for imaginary part. So we shall put here this have x1 x2 minus y1 y2. Here y shall put this x1 y2 plus x2 y1. Are we there? Then here the negative of this, so it is minus x1 y2 minus x2 y1. Then here the real part, this one x1 x2 minus y1 y2 as that. Are you getting the connection? As that. So on the other hand, you can say, we can find now f z1 f z2. So fz1 will give us x1 y1 minus y1 x1, then fz2 will give us x2 y2 negative y2 x2. So we get the product. We get the product of this to this f z1, this is f z2. Remember, fz is given by this, and z is given by x plus y I. but fz is given by x, y, negative y, x. So fz1 will give us x1, just 1. I'll just put 1, 1. If fz2, just put x2, y2. Simple as this. Hope you understand. So we get the product. We shall have x1, x2 plus negative y1, y2, x1, y2 plus y1, x2, then x2, y1 plus minus x1, y2, negative y1, y2 plus x1, x2, and now you have x1, x2 minus y1, y2, x1, y2 plus y1, x2, then negative x2, y1 minus x1, y2, negative y1, y2 plus x1, x2 plus x1, x2 as fz1, fz, fz2. At that point you can see that this one and this one are similar. So we have proved that, we have shown that fz1 z2 is equals to fz1 fz2, as you have seen. Thank you so much for watching. Till next time, please kindly consider subscribe to my YouTube channel for more videos to come, for more lessons to come. Bye bye.